All right, welcome, APE students. I'm going to be going over the multiple choice questions that I put out to you for air pollution, the air pollution quiz. So this will be pretty brief. I'm just going to go over the questions and discuss any little extra information I might want to give you on them. So for the air pollution quiz, question 1, the layers of the atmosphere, the correct answer is B, troposphere, stratosphere, mesosphere, thermosphere. The two that you need to be most concerned with are the troposphere, the ground level, going up to 10 kilometers, and the stratosphere going from about 10 kilometers up to 50 kilometers. And so, mainly we deal with stuff in the troposphere. Which gets to question 2. The atmospheric layer containing 75% of the mass of Earth's air is the troposphere. That's where most of the air molecules are. As you go up in elevation, there's just less and less in terms of actual number of particles, and that continues as you go up. Question 3. Stratospheric ozone is responsible for all of the following except lowering atmospheric water vapor. Stratospheric ozone is the ozone layer that's about 20 to 30 kilometers up. It's a thick layer, but if you compressed it to standard temperature and pressure, if you remember that from chemistry, so basically if you brought the ozone layer down to the ground, it would be 3 millimeters thick. Incredible that small amount, in some ways you could look at it as a small amount of ozone actually does so much. It screens out ultraviolet radiation, so important for life on Earth, on land. Water does a good job of blocking UV, so life could evolve before this in the water, but it really took the formation of the ozone layer for life to be able to successfully colonize land. Yes, protects us from sunburns, also huge, right? I mean, that's essentially why UV radiation is bad, because it causes damage to DNA, which can lead to cancer. 4, human health depends on B, having enough ozone in the stratosphere and little ozone in the troposphere. Can't be zero ozone in the troposphere, but little ozone, but you want enough in the stratosphere. So stratosphere ozone, good, blocks UV radiation. Tropospheric ozone, not good, because it causes health problems. So human health, damage to lungs. Question 5. Human inputs of outdoor air pollution occur mostly in urban areas. Obviously, areas where there are lots of automobiles, areas where there are factories. Farming to some extent is also a factor, but really the worst sort of concentrated sources of air pollution are going to be in urban areas. Question 6. Photochemical smog is formed when primary pollutants interact with sunlight. So it's actually UV radiation that's doing a lot of the the changes there. And I have a video that I am going to attach to this that talks about specifically how ozone is formed through the interaction of VOx, NOx, and sunlight UV radiation. The difference between primary and secondary pollutants is very important. You need to know primary pollutants are released directly. So for question 7, primary pollutants from burning coal include all of the following except ozone. Ozone is not a primary pollutant. It's not produced directly, it's produced indirectly. Burning coal will ultimately result in the production of more ground level ozone, but that's only through interactions, again, with specifically UV light. A temperature inversion is when, and I explained this in the previous video, is when you have a make sure I get this right, because I don't want to tell you the wrong thing accidentally. You have a lid of warm air and cool air comes underneath it, and now as the pollutants rise through the layer of cold air, they hit that layer of warm air and they get trapped, and you get basically smog and other ozone and other pollutants that can build up underneath that lid of warm air. So question 8, the answer is C. Question 9, one of the strategies of the following strategies to reduce acid deposition, the least effective is probably adding lime to neutralize the acids. Think of the large area that's going to be covered with acid rain, acid deposition. Lime is, limestone will neutralize it. So soils that are naturally, have limestone are actually more resistant to acid deposition. So this is, important regionally in terms of what type of soil is around in determining how much impact acid deposition has. But as a strategy to deal with it, we can't go around spreading limestone over everything. I mean, that's just not really going to work. Now, if you have a lake that's a drainage, where there's a bunch of water that has built up that's acidic, it might be possible to neutralize that location, but that's not a great, again, overall strategy to go in after there's already damage and try and fix it. So the other methods are all good. Removing sulfur from coal before it's burned, you can basically leach it out, but then you have all that sulfur. It's got to go somewhere. And that's also, a problem with removing pollution in terms of the wet scrubbers, which are on the smokestacks that collect the sulfur dioxide, and those are going to create pollution. You're going to have now some sort of solid or liquid slurry that you have to deal with. So, of course, the best way to go about it is not burn coal. We know that. Don't burn the coal. Reduce energy use. I'd say that switching to natural gas is probably a little passé at this point. Nope, not switching to natural gas either. That would be effective at reducing acid deposition, but that's kind of a, we don't want to trade one bad energy source for another. So we're on to wind and solar now. Improving energy efficiency, though, of course, if we can reduce our energy use even more and more and more, then we need to get less from wind and solar, which makes it more feasible. All right, on to question 10. Radioactive radon is the product of uranium decay and an important indoor air pollutant. Question 11. What do all volatile organic, keyword there, organic compounds have in common? They're all carbon-based. Remember that, that word organic has a specific meaning, which is carbon-based. 12. Harmful chemicals emitted directly, there's the key word, directly into the air. That would be a primary pollutant, right? If it's emitted directly, that's primary pollutant. So 12 is E. 13, which of the following would not be a factor that reduces outdoor air pollution? And that would be E, radiation from the sun converts pollutants into benign chemicals. I know you might say, well, didn't you say that there is a conversion, but it's actually the other way. It's converting things into ozone, which is not a benign chemical. It is an active chemical that can cause damage to lungs. And then lastly, volatile organic compounds, VOCs, VOCs, contribute to tropospheric ozone pollution by removing nitrogen oxide. So nitrogen oxide, NO is the chemical formula there. And again, I attached a video which explains a little bit more about those interactions. So, all right, guys, enjoy. I'll also have another video going over the free response question. So I'll be posting that in a bit. And hope you're doing all right. Make sure you're keeping up with the reviews. We're gonna, get into more of that soon here. So if you need to go back and do some of those reviews for the previous units, that would be a good idea so that we can start going over those. All right. See ya.